Now we will look into another way of characterizing the systems, that is called causality. A system is said to be causal if output at any instant depends on input at that instant or past inputs. Otherwise, the system is called non-causal. Also, if the output at any instant depends only on future inputs, then the system is called anti-causal. So we see that causality implies the output at any instant depends on present or past inputs, and anti-causality implies that the output at any instant depends only on future inputs. Non-causality implies that the output at any instant depends on past inputs, depends on at least one future input. For example, y of n is equal to x of n minus x of n minus 1. If you take, in this case, the output at any instant depends on past or present input, so the system is causal. If you take another system, y of n is equal to x of n minus n plus 1, in this case, the output at any instant depends on future inputs only, so the system is anti-causal. Also, anti-causality implies non-causality, so the system is non-causal as well. Now, if you take another system, y of n is equal to x of n plus 1 minus x of n minus 1. In this case, output doesn't only depend on future inputs, so the system is not anti-causal. Also, output doesn't only depend on present or past inputs, so the system is not causal. That implies the system is non-causal. From this, we see that um, if the output depends on past or present inputs only, then the system is causal. If the output depends on the future inputs only, then the system is anti-causal, and hence would be non-causal also, as anti-causality implies non-causality. Also, if output depends on both past and future inputs, then the system is non-causal, and also it wouldn't be anti-causal. Now we will look into another way of characterizing the systems, that is by memoryless property. A system is said to be memoryless if output at any instant depends on the input at that instant only. So for example, if you take the system y of n is equal to 2 into x of n plus 3, we see that the output at any instant n depends on the input at that instant n. So this system is memoryless. Now if you take another system, y of n is equal to x of n minus 3, in this case we see that the output at any instant depends on past inputs because of the n minus 3 factor. So the system is not memoryless, hence the system has memory. Now if you take another example, y of n is equal to x of n plus 2 multiplied by x of n. In this case, the output at any instant depends on the current input and the future inputs also. So in this case, the system has memory as it depends on the future inputs. Now let us solve some problems related to the causality and memoryless property. Let us consider a system which is described by the relation y of t is equal to x of t into x of t minus 1. We have to find if the system is, or we have to characterize the system based on causality and memoryless property. In this case, we see that the output at any instant t depends on present input, that is x of t, and past input, that is x of t minus 1. So the system is causal. Also, the system has memory as it depends on the past inputs. So the system requires some memory for the implementation. So based on these, we see that the given system is causal and has memory. Now let us consider a system y of n is equal to sine of pi by 2 multiplied by n minus 1. This further multiplied by x of n. So you have to characterize this system based on causality and memoryless property. In this case, we see that the output at any instant n, that is y of n, depends on the input at that instant, that is x of n. In this case, the output doesn't depend on the past inputs like x of n minus 1 and so on, or x of n plus 1 and so on. So as the output doesn't depend on these inputs, we see that the system is memoryless. Also, the output at any instant depends on the current input only, so the system is causal as well. So from this we see that the memoryless property implies causality, but vice versa is not true. Now let us consider another continuous time system which is described as y of t equal to x of t minus 1. This is for t less than 0. X of t, this is for t equal to 0. And x of t plus 1, this is for t greater than 0. We have to find if the system is, or we have to characterize the system based on causality and memoryless property. We see that for t less than 0, y of t is equal to x of t minus 1, and in this case it depends on the past inputs strictly. So definitely we can say that it is not memoryless, hence has memory, but it could be causal. So for that confirming the same, we have to check the remaining time cases. So for t equal to 0, y of t is equal to xt, x of t. So still it could be causal, but definitely it has memory based because of the previous case. But for t greater than 0, y of t is equal to x of t plus 1. So in this case, the output at any instant depends on the future inputs. So in this case, we see that the system is not causal as it depends on the future inputs. And also we found that it's already has memory. Now the question is if it is anti-causal. The system is not anti-causal as it depends on the past inputs for t less than 0. So while evaluating causality or memory less property, we have to check the properties for all time periods. So from this we see that the system has memory, and also it is not causal, and also it is not anti-causal. Now let us consider another system which is represented as y of t is equal to t cube into, sorry, x of t square. We have to find if the system is causal or memoryless. In this case, if we see for t less than 0, y of t is equal to x of t square. Means say if t is minus 1, or if t is minus 9, I have just taken an example here. So y of minus 9 will be equal to x of 81. It means that the output at t equal to minus 9 depends on the future input. So from this we see that the system is definitely not causal, but it could be, and also it's definitely has memory. Now we have to see if the system is anti-causal, if at all. Now for t greater than 0 also, y of t is equal to x of t square. Say if you consider t equal to zero point 0.1, in this case y of 0.1 is equal to x of 0.01. In this case, we see that the output at any instant depends on the past input. So in this case, definitely it's not anti-causal. From this, we see that the given system has memory, it is not causal, and it is not anti-causal. Now let us consider another system which is discrete time, which can be represented as y of n is equal to x of n square. Now we have to find if the system is causal and memoryless. So if we consider, say, for n less than 0, y of n is equal to x of n square in this case. So if we consider, say, the instant n equal to minus 9, y of minus 9 is equal to x of 81. Here I have taken the instant n equal to minus 9 just for example's sake. So in this case, the output depends on the future inputs. So the system is not causal and it has memory. Now, if we consider the instant, now if we say for n greater than 0, y of n is still equal to x of n square. Now, if we consider, say, n equal to 0, actually this is for n greater than or equal to 0. If we consider n equal to 0, y of 0 is equal to x of 0. So in this case, the output at n equal to 0 depends on the current input. So the system is not anti-causal, as it should depend on the future inputs only. From this, we see that the given system is not causal, not anti-causal, and has memory. Now let us consider another system. Y of n is equal to f of n multiplied by x of n plus g of n. In this example, the functions f of n and g of n are polynomials of n. So we have to characterize this system based on the causality and memoryless property. Please note that the functions f of n and g of n are non-zero polynomial, have non-zero, at least one non-zero polynomial coefficients. So in this case, if you see, the given system is y of n is equal to f of n multiplied by x of n plus g of n. So the output at any instant depends on the current input only. This is for every n. From this, we see that the given system is memoryless and also causal, as memoryless property implies causality. Now let us consider another system. Y of t is equal to integral minus infinity to t x of t. We have to find if the system is causal. Now if we see, the system y of t is obtained by integrating the inputs from the range from minus infinity to t. So in this case, we see that the output at any instant t depends on the past inputs only, because the integration is from minus infinity to t. From this, we see that the given system is causal. Also, the integration happens from minus infinity to t, so the system has memory. Now let us consider another system. Y of t is equal to mod of x of t. We have to find if the system is causal and memoryless. So we see that in this case, the output at any instant t depends on the input at t only. From this, we see that the given system is causal, and also we see that the given system is memoryless. This is the case because the output at any instant y of t depends on the input at that instant, as it is mod of x of t. Now let us consider another system. Y of n is equal to n square into x of n. Sorry, n square into x of n plus 2 plus n into x of n minus 1. We have x of n plus 1. Sorry, the given system is y of n is equal to n square into x of n plus 2 plus n into x of n plus 1. We have to find, or we have to characterize the system based on causality and memoryless property. We see that the output at any n depends on the future inputs only. From this, we see that the given system is anti-causal. That implies the system is non-causal. As the output at any instant depends on future inputs only, also we can say that the system has memory. So based on above problems, we can deduce some principles. So they are as follows. The memoryless property implies causality, because if the system is memoryless, it should be causal. Anti-causality implies non-causality, because if the system is anti-causal, it implies that it depends on future inputs only, and hence it should be non-causal, as the system would be non-causal if it depends on at least one future inputs. Also, please note that causality need not imply or doesn't imply memoryless property, because causality means the output at any instant depends on current and past inputs only, whereas in case of memoryless property, it should depend on the current input only. And non-causality doesn't imply anti-causality. This is the case because if the system is non-causal, the output depends on at least one future inputs, and it should get, and it is still could depend on the current and past inputs. Whereas in case of anti-causality, the output should depend on the future inputs only. From this, we can deduce that anti-causality doesn't imply non-causal, or sorry, anti-causality implies non-causality, but non-causality doesn't imply anti-causality. Now let us consider a system y of n is equal to sigma m equal to minus infinity to n f of m multiplied by x of n minus 1. It's given that the system is memoryless. Then we have to find the appropriate f of n for which the given system is memoryless. So for the given input-output relation, y of n can be written as and so on f of minus 2 multiplied by x of n plus 2 plus f of minus 1 multiplied by x of n plus 1 plus f of 0 multiplied by x of n plus f of 1 multiplied by x of n minus 1 plus f of 2 multiplied by x of n minus 2, and so on. But the system is memoryless. For that to happen, there should be only the term corresponding to f of 0 into x of n, and the remaining term should be 0. But the remaining terms need not be 0 for any generic x of n, and those terms would be 0 if and only if f of 1 equal to f of 2 equal to and so on equal to f of minus 1 equal to f of minus 2 equal to and so on are 0. For this to happen, f of n should be a impulse function of the form k into delta n. From this we see that the given system is memoryless if and only if f of n is of the form k into delta n, means it should be a impulse function. Now there is another discrete time system given, which is of the form sigma m equal to minus infinity to n f of m multiplied by x of n minus m. It's given that the system is causal. So for the system to be causal, find out the condition that should be satisfied on f of n. So for the given input-output relation, y of n can be expanded as y of n equal to and so on f of minus 2 multiplied by x of n plus 2 plus f of minus 1 multiplied by x of n plus 1 plus f of 0 multiplied by x of n plus f of 1 multiplied by x of n minus 1 plus f of 2 multiplied by x of n minus 2 plus and so on. It's given that the given system is causal. In this case, the terms corresponding to x of n minus 1, and x of n minus 2 could be present, but the terms corresponding to x of n plus 2 and x of n plus 1 should be 0. For that to happen, for any generic input, f of n should be equal to 0 for n less than 0. It means that the given system is causal if the function f of n is equal to 0 for n less than 0. Now let us consider another system. Y of t is equal to x of t minus x of t minus 1 for t greater than or equal to 0. Sorry, for t greater than 0, and it is equal to x of t. This is for t equal to 0 and y of t is 0 otherwise. We have to characterize the system based on causality and memoryless property. We see that for the given system, the output y of t at any instant depends on past inputs for t less than 0. So from this we see that the given system has memory. Also we see that the output at any instant depends on past and present inputs only. From this, we see that the system is causal as it doesn't depend on future inputs. So, as the output at any instant doesn't depend on the future inputs, we see that the system is causal, and also the output at some instant depends on the past inputs. So, the system has memory. From this, we see that the system is causal and has memory. Now, let us consider another system. Y of n is equal to x of mod n. We have to find if this system is causal. We see that for n less than 0, y of n is equal to x of minus n. So in this case, we see that the output at some instant depends on future inputs only. Similarly, for n greater than 0, y of n is equal to x of n. So in this case, the output depends on present input only. It even doesn't depend on the past or future inputs. From this, we see that the given system is non-causal as it depends on both present and future inputs, and also it has memory.